7.6 is on right triangle similarity. So we're going to identify similar right triangles and use proportions to solve for missing lengths. So if we have an altitude, which is from a vertex straight down to the opposite side, forming a right angle, if we have that in a right triangle, it is going to form two more right triangles that are smaller. So we have one that's highlighted in yellow now and one that is in green. So these two right triangles are similar to the right triangle that was originally drawn. So by drawing that altitude, we form three similar triangles. So these are similar to the original triangle and each other. So all of these triangles are similar to each other. So when we have our similar triangles, we're going, when we need to, have to draw all three of them. So the first one I'm going to use is for the smaller one that I've highlighted in yellow. So you can use the triangle to see which leg is shorter, and that would be FJ in this case. That is always going to be the side that I'm going to draw going up and down, just so I know I have a pattern to follow. So the short leg is going to go up and down, and then the long leg is going to be horizontal. Then, if we draw our second triangle that's formed, the medium length one, I'm going to draw it in the same order, where I have my longer leg horizontal and my shorter leg vertical. So that would be G, J, and then H. And J was where the right angle was, so that's why my right angle would be there. And lastly, we have our original triangle, which was the larger one. And again, my longer leg is going to be horizontal, which by looking at this one would be H, G, and then my shorter leg would be G, F. Oh. Now that I have them all drawn in the same orientation, I can go ahead and name them. So we have triangle GJF is going to be similar to triangle HJG, which is going to be similar to triangle HGF. And that is how you can name all three of our similar triangles. Using that information, we are going to solve this example here. A cross-section of a group of seats at a stadium shows a drainage pipe, which is labeled BD, and I've highlighted that in yellow, that leads from the seats to the inside of the stadium. They want us to figure out the length of that pipe. So if I start by drawing my triangles so they're all going in the same orientation, I'll start with the smaller one. And the longer leg on that one is going to be X. And we are given also the hypotenuse, which is opposite of that 90-degree angle, which would be 20 feet. Then we can draw our medium-sized triangle. And D would be our right angle, B and C. The hypotenuse there is 30 feet, and the shorter leg is X. And lastly, our outside triangle, ABC. ABC has a hypotenuse of 10 square root of 13, the longer leg of 30, and the shorter leg of 20. So these would be our three triangles. You won't need all three of these to solve for x. We just need to find two that are proportional to each other. So looking at this, X is on the longer leg, and in that triangle, we also know the hypotenuse. So we want to use a triangle that has the longer leg side and the hypotenuse. So we're not going to use the medium-sized one because it doesn't have that leg length there. So we're going to stick with the larger triangle. Now that we have our proportional sides, we can set up our equation. So we can do 20 over 10 square roots of 13 equals x over 30. Then we can cross multiply. 20 times 30 is going to be 600 equals x times 10 square root of 13. This is where we will divide both sides by 10 square root of 13. And if we took 600 divided by 10, that would be 60. So this is the same as 60 over the square root of 13 equals x. And this you can type into a calculator to get a rounded answer. So if I pull up my calculator here, we have 60 divided by the square root of 13, which would be about 16.6. And that would be our final answer. And this would be in feet. So that's one way that you can use these similar right triangles to solve for a missing side length. Our next example, they want us to identify the similar right triangles and then find the value of x. So for this one, again, I'm going to start with the smaller one. And my longer leg is going to be horizontal. So we're going to have G, F, D. We know DF has the length of x and the hypotenuse is 6. Then my medium-sized triangle, I'm going to draw that one. Going in the same orientation, my longer leg is horizontal, which in this case we don't know the length of the longer leg, but the shorter leg is x and the hypotenuse is 8. And the points would be D, F, and E. And lastly, we're going to do that outside triangle, which D would be the hypotenuse, G, and then E. So if we were to write our, gotta label our lengths, we would have 10, 6, and 8. If we were to write our similarity statements for this, we would have D, F, G is similar to triangle E, F, D, which would be similar to triangle E, D, G. Now that we have those written, we identified the similar triangles. Now we need to find the value of x. So if we look, x is the shorter side of the triangle. So we need to find one of our three triangles that also has the shorter side labeled. The first one doesn't, the smaller one, so we can't use that one. But the third triangle does have that. And we also have the hypotenuse on both of those, so this will be a good fit. You could have also, if you noticed, used the first triangle and the last triangle, but it's also going to work by using the last two. Using that information, we have 8 over 10 is going to be equal to x over 6. And we can go ahead and cross multiply. We will get 10x equals, and 8 times 6 would be 48. and then we would divide by 10, we will get 4.8 for our answer. Okay. One other example that we're going to go through, we're going to skip the second one, but we will go over the geometric mean one. So the geometric mean in a right triangle is going to be equal to the altitude. So this one would be point D and point C. So for this, DC is going to be going on the top and the bottom. And if you remember when we first set up our geometric mean before, we would have A over X equals X over B. And the geometric mean would be equal to X. That geometric mean is going to be working in our favor to help us solve some of these problems where we have an altitude. So in this one, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. And the length of the altitude is the geometric mean of the lengths of those two segments. And if you remember, the equation for the geometric mean would be x equals the square root of a times b. Now we're going to use that equation to help us in an example. So for this one, we are going to be working with an overpass. And to find the clearance under an overpass, you need to find the height of a concrete support beam. So they want us to find the total height here. I'm going to label that, I guess H would make sense. So we'll label that H because we are looking for the height. So we have the square for our right angle there because they use a cardboard square to line up the top and the bottom of the beam. And they've measured the vertical distance from the ground to your eye and the distance from you to the beam. They want you to approximate the height of the beam. So to do that, we know the altitude from the right angle is going to be equal to the geometric mean. And when we set up the geometric mean, we have two fractions equal to each other. And the geometric mean goes on the bottom of the first one and on top of the second one. And then the two segments that are formed by that altitude are going to be the numbers that go on the missing spots. So we would have 5 over x. Then from here you can cross multiply. So we would get 6.9 squared, which would be 47.61 equals 5x. Then we will divide our answer by 5 to get 9.522 for our value of x. Another way, if you forget to this, we can also, because we know this is our geometric mean, we can do 6.9 equals the square root of x of 5x, because we would take it times 5. Then we could solve this equation. So to do that, we would just square both sides to get rid of the square root, and we would end up with the same answer. So this is just another way that you could solve this problem to get x. And remember, our final answer for this question was to find h, and that would be equal to 5 plus the 9.522. So we'll get h equals 14.522, and this one is measured in feet. Our last example would be to find the value of y. And It's okay if you don't write it in simplest radical form. You can give a rounded answer. So we'll start by drawing our 3 triangles. Again, we have our smaller one. And this one would be MJK. This has a length of Y and 9. Then our medium-sized triangle. We will have LMK. And this one we aren't given any of the exact side lengths, but we could figure out what LM is by taking 24 minus 9, which will give us 15. So we know LM is 15, but we don't know any other of the sides on that triangle. And then lastly, our outside triangle. We can draw that one, which has the right angle at K. The smaller side is KJ, and then L. So we are solving for Y in this one. And to do that, we need to figure out which ones can go together. Oh, that's why. I was looking at this and trying to figure out what to do. I put my Y in the wrong spot in my first triangle. This is across from the 90-degree angle, which would make the Y go there. So when we're looking at this, we have Y on the hypotenuse. Looking at our middle triangle, we are not given the length of the hypotenuse, so we're not going to use that one. It won't be very helpful. Using our last one though, that one has the length of the hypotenuse and then the shorter side, and that's also what we have in our first triangle. So now we can go ahead and set up 2 fractions that are equal to each other, and that will allow us to solve for Y. So in this one, my purple highlighted sides will go together, which will be Y over 24, and then my blue highlighted sides go together, which will be 9 over Y. You'll notice you'll end up with Y squared because you have Y times Y, and then we have 24 times 9, which will be 216. Then we need to take the square root of that value to get Y, and you can round your answer, and this one will be a 14.697, and that'll be our value for Y. That is the end of this section. You'll notice on the homework assignment for this, there's some on right triangles and then review problems. So if you have any questions, just let me know and I'll get back to you as soon as possible.